Now let's look at some of the binomial cumulative problems where we're going to be adding or asking our calculator to add together some values. You could use the formula for these problems, however it's very cumbersome to use the formula to find maybe 68 values like you would need on the problem after this one, so we'll just use our calculator. This example, if you flip a fair coin 10 times, what is the probability of obtaining at most 5 heads? So what I need you to do every time you see one of these problems is make note of your n, p, and your x. In this case, n is 10 because that was the number of trials. What is the probability of obtaining at most 5 heads? So you're looking for the probability of a head. If you have a fair coin, that's 1/2. Because either it's heads or tails. And then again back to the at most 5 heads. So 5 is the largest it can be, so we need all the probability values before 5 including 5. Add those all up and we'll get the probability of at most 5 heads. So here's what we want. We want the values, or the probability values, for 0, 1, 2, 3, 4, and 5. The calculator will do this for you. It will start at 0 and accumulate all those up for you all the way up to 5. So the probability that x is less than or equal to 5 is equal to, we're going to do binom CDF. Our number of trials will be 10. Probability is 0.5. And then we're going all the way up to 5. We should get 0.623. Now on the calculator, I've ran this on the calculator, and we do get 0.623. Let me show you what steps. So we're going to press second, distribution, and again you want to page down until you see binom CDF. Here's our binom CDF. For me it's going to be alpha B if I want to go directly to it. It could be something different for you. So then I'm going to press enter. Under number of trials, 10, probability 0.5, x value, we want it to add 0, 1, 2, 3, 4, and 5, so we're going to put 5 there. So page down to paste, and press enter, and enter one more time, and it gives us that result, the 0.623. Going back to the slides for the next example. An airline estimates that 97% of people booked on their flights actually show up. If the airline books 70 people on a flight for which the maximum number is 68, and they actually do that, and they use these methods to figure out if they can do that, what is the probability that the number of people who show up will exceed the capacity of the plane? Now again, I've made note, what is my n? That's 70, the number of people booked. That's going to be my number of trials. The probability that a person actually shows up is 0.97. We want to know the probability that it will exceed capacity. If the plane holds 68 people, exceeding capacity means that more than 68 showed up. So x is greater than 68. That would be that 69 showed up or 70 showed up. So we want, or we need, to add together the values for 69 and 70. However, the calculator won't add 69 and 70 for you. If you go in there and you put in 69 as your x, it's going to give you the values for 0 all the way up to 69. If you put in 70 for your x, it's going to give you the values for 0 added all the way up to 70. You don't want that. What you do want to do is subtract those values or up to 68 from 1. So 1 minus, and then we're going to ask it for the values up to 68. So the binom CDF, and our number of trials was 70. Our probability value is 0.97. And we're asking it to add all the way up to 68 and subtract that from 1 so that it gives us the sum of 69 and 70. Okay? So that will be 0.375.